Good afternoon, everybody, and welcome to the Solid Edge with Synchronous Technology Sheet Metal and Frame Design webinar. My name's Mark Fort. I'm the Technical Manager for Edge Software, and I'm joined today by John Belsham, who's listening in Melbourne, and also Lee Northend, who's up here in Queensland. We're going to be taking a quick look at the productivity of the sheet metal environment and the frame design environment, which tend to go together quite often in the Solid Edge environment. Just a quick introduction to Edge PLM Software Proprietary Limited, for those who don't know us. We've been around since 2003, and we were set up to sell and support Solid Edge and its associative products. We have quite a wide range of products that go around the Solid Edge product. We have CAM products, simulation products, and data management products. So there's a complete suite of products and services that go with those products. So we offer full training, mentoring, and a full hotline support organization that's the services organization is designed to provide you with productivity for your software. It's fine to have software, but if you don't know how to use some of the aspects of it, it doesn't really help you. So through training and a support organization, we can guarantee you that you'll get the best productivity out of your software. We've got offices in Melbourne, Sydney, and Brisbane. What this is all about is working more efficiently. We all have customers who want more for less. Time frames are shortening, products are becoming more complex, demands of government and everybody else are set to try us. So how do we at Edge and with Solid Edge provide a solution for these? We're all aware that 3D is the way to go and has been for many, many years, but how do you get there? There's risk involved in implementing new software. We've been working with 2D for many years. We know that works. We've got a huge investment in our existing 2D drawings. These are the questions that Solid Edge answers. Ease of use. We can transition slowly from 2D to 3D, and we can reuse all your existing 2D information. What's different about Solid Edge in this industry is that it's more like your 2D system to use than other 3D systems. What that means is that you don't have to have a deep understanding of history and interpart associativity and precedence, parent-child relationships, and those sorts of things to be able to create and edit data. If we just look at a very simple example, I want to take all these features that are on the end of this this component and move them by some amount to the right, maintaining the dimension between the cutout and the half circle cutout and the circle cutout. All we have to do is, same as you do in 2D, draw a box around it, move that box the distance that you want to go to the right, and the part updates. It just does what you want it to do. So it's a much more straightforward method of going about things. I could talk about it all day, quite obviously, but let's take a look at how this is going to work for us. So let me switch over to Solid Edge. A slight switching here, so bear with me. Okay. Here's the Solid Edge startup screen. I'm going to make a sheet metal component, but we can see we can make mechanical parts, build assemblies, create draft files. We have all our help over here. We can link to online tutorials, built-in tutorials. All of this is on our start page, makes it nice and easy. So I'm going to start off with a sheet metal component, and it just brings up a template, a blank part if you like, for me to start working in. Now I need to give it some characteristics, so I'm going to go to my material table and say, what are we going to make this out of? Well, We're going to make it out of 304 stainless. And what's the material thickness? This is a solid edge component, a solid edge sheet metal component. So we need to go to our gauge table. I'll just pick up this one for steel, and I'm going to pick up 10 gauge. I want to make it 10 gauge steel. Let's have a look at how that works. What that is doing is referencing a spreadsheet. Now the spreadsheet has the gauge in it. This happens to be in imperial, and because we're in a metric part, it'll automatically translate it into millimeters. But the clever thing about this is it will give us the setbacks or the neutral factor given different radiuses and different angles of bend. So you can program up this. We provide some proformas for you to work with, but you can program this sheet up so that for, you can go as fine as every 1 degree of angle if you want to. You have the appropriate neutral factor. So it's correct bending. It's bend by bend neutral factor setting. So it's very accurate. Okay, let's apply that to the model and start creating some geometry. So first thing we're going to make is a simple mounting bracket. I'm just going to start drawing. So my quick menu here, my radial menu, I pick the line draw command, and I just draw some lines that are horizontal and vertical. A little glyph comes up next to the cursor to show me what's going on. Again, I'm going to use my radial menu to pick a contour flange, drag that out. I want to make it symmetric, and let's make it, it's picked up the material specifications we put in a moment ago, 120 millimeters, and enter, and it gives us our part. Okay, that's fine. I want to add some rounding to this, and I just have to click to put those edges on. Very simple, very quick. And I want to taper these edges so that we've got a component shape that way. I want to create a cutout in there, so on that face, on the center of there, size in, and just cut that through. Just select the region, grab and go handles will cut through. Don't have to think about it, don't have to worry about commands. Now, this needs to be, and one of the essential design requirements for this, go to a dimension here, is to have the center of that hole exactly 100 millimeters from the back face. So let's make sure that that does it. The rest are approximate. I don't really worry about the rest too much as long as it sort of looks right and holds together correctly. And okay, now we need to put some flanges on the side here for a bit of strength, so we just pick those edges. We've got a flange start handle here. We pull it up, and we've got our flange properties in here, which are all fine. But for the moment, I don't really need to know much about those. I just want to bring that flange up to that edge, which is fine. And what we want to do now is close those corners. So back to my menu, I want a 2-bend closed corner, pick those. I can set that up in a number of different ways. I've got circular cutout set here, but I can have U-shape, V-shape, squares, miters, opens, and so on. I'll just use the circular cutout. I'll leave a 6 millimeter, and again, same thing there. So later on we'll see in draft we'll put some weld detail in there. Still 100 millimeters. The overall height of this I want it to be, let's say, not there. All right. All right. I want that to be 50 millimeters, so I'm going to bring that down 50 millimeters, to 50 millimeters, sorry. You'll notice that I just affected that face to begin with. It went blue, and because of my live rules here that's inferring what I want to do from the geometry, it said, okay, I'll pick up the coplanar faces and bring those down as well. I could turn off that rule if I wanted to leave those faces high. Obviously I don't. Final thing that I want to do here now is just to clean up this, make it look a little prettier. Just put my steering wheel here. You notice I'm doing all my manipulations with the steering wheel. I pick on the torus here or the circle around it to lay these back, and I'll lay them back to about there. And the two dimensions that are critical for this, the height here and the depth here, are in. One more thing that I want to add to make it a little stronger is we want to add a gusset. So I put a gusset on that bend and just put it right in the center there. Now when we place the gusset, we can set all its characteristics, and here I preset that for depth of 20 and the punch and die rounding, etc. This is placed in after it's bent. So this is a post-manufacturing operation. One more thing before we finish, and I've got enough here now, I need to put some properties, more properties on this, and some file properties. So I want to give it a name, and it's a bracket. We want to give it some project details, so a document or part number. A revision, it's the first one, so I'll make that an A. It'll automatically increment that as we go. We might have a project that we want to apply this to. I can put custom properties in, as many as I like. I might say I want one called cost. And we'll make that $2.99. There we go. We can add that in. All of that information I place in can be extracted later into bills of materials, etc. Okay, let's save that as just give it a part name, and let's make a drawing. So we picked up a template, our standard template. Next, I want to take a right view as my primary view, top, isometric, and end view. Finish and just place those views. This view here, I want to place that as a colored view, shaded with edges. We can extract dimensions from the model where the dimensions are. We can also place our own dimensions. So we want to have and I want to place a dimension from the end of there through to center there. It's obviously 100, and also we might want to put another one from the end there, but to the outside of the radius here, and so on. Now, the other things that we might want to do are to lay out a flat pattern. Now, we didn't do a flat pattern, so let's just go back to our model and flatten that model. I go to our tools, I want to create a flat pattern, and it's as simple as that. So it's laid out my flat. We can see how it's developed. We can see the edge lines and what have you. Let's take that back, save it, and go back to my go back to the drawing. Because we've made some changes, the drawing views may have been changed. They haven't in this case. We've just added a flat pattern. I'll insert another sheet, and we want to take that bracket again, but this time have a look at the flat pattern. That's always the top view we take of a flat pattern, and place that in there. Another thing that we might want to do, if we go back to our model very briefly, is set up a bend table. Now, in this bend table, you can see the bends. It's number 1, 2, 3, and so on. I might want to put that one before that one. This is a fairly simple sequence. If you've got a complex sequence, you can program that sequence so it's exactly right. If we come back to our draft, update everything, but what I want to bring in is my tables, and I want to bring in my bend table for this and place it there. So we've got number 1, number 2, number 3, and the radius of those bends and the angle. So what we've seen here is a complete process of creating the part. One thing that I didn't mention before is because I put the material properties on there, if we look at our properties, we can update that and we get the correct mass, we get our center of mass, center of volume, principal axes, so all our 3D properties. It gives our volume, our surface area, and so on. So if we look in our draft, which we saw before, we see down in here, let me zoom into there, we picked up the title, we picked up the drawing number automatically, we picked up the weight and the fact that there's 2 sheets in there. So, okay. That's just a simple sheet metal part. What I'm going to build now is a frame of a truck. So we're going to put together a little truck body, if you like. We start off in an assembly, and we're going to, apologies, the wrong one. I've got to find the document. Aha, I didn't set this up beforehand. That'll do. Okay, what I'm going to do is to, on this sketch, let's bring it up so you can see it and explain what we've got here. I've just got a very simple layout of the truck. Here's the 2 wheels. What's important here are the mounting areas and the chassis rails. So these mounting areas we want to apply to our model. So I'm going to draw the outline of what I need. And it's going to be very, very simple. We just align this to the sketch that came from the truck manufacturer a little bit. We put some dimensions on it. Make it 1500 wide. We make it 2500 long would be good, wouldn't it? If I can type, it always helps. We'll put some cross members in there. So I want to have a cross member across here. I want across here. And I'll place that one down there a little bit. And we want to place a dimension from here to the center as well. And we'll make that 1200. Okay, one thing that we need to have here is I need to have a known spacing between these and these are the cross members and the center of the hole here. So again, put in a dimension from there to the center of there, and I'll make that 100. And the same here. So again, the center of there to there. Make that 100. Okay, we can close that sketch. We've got our basic layout for our chassis. We don't need to see the first sketch. And we've got a simple layout here for our chassis. One other thing that I might add to the sketch, I go back to that, and we're going to edit that profile, is I'll put some alignment lines for my doorway that I'm going to put in here. So I'm just going to put 2 of those in. And we just put some dimensions on those. So from here to here, we want to make it so 1 meter wide, and then from there to there, we might want to make that, say, 600. Okay, and because I don't want to use those, I'll just make them construction lines. There we go. Okay. Now we're going to use our framing environment. So we go to our tools, pick up our frame environment. I already had a frame set in there, so let's get rid of that so we can recreate it. Okay, so we want our drawing tools here, and the first thing I'm going to make is just set the height of this a little bit. So I want to pick the midpoint of that edge, and I'll just explain this little 3-axis gnomon here. What I'm going to use is keyboard shortcuts. So if I click on the Z key, it'll pick the one of the three axes. So each time I press the Z key, it steps around. So I want to go into the Z key. I want to make that 1100 high. And I click, and it places it there. Now I want to go across in the X, and I want to go across 300. All right, I'm going to start from here. And we want to pick up an end point here. And straight up in the Z, and this one's going to be 750. Once I've got this basic information in here, and then I want to be on the plane here, this ZX plane. So if I press the X key, I step around the plane. So there we go there. So again, come out here, the Z and the X at least, 300. And up that one. Now this time, because I've got a height here, I don't even need to type in a height. I just say to the end point of that, it'll make that the same. Pick my plane and lock onto there. Now I want to have the same down this end. So again, it's a matter of just going up in the X to that height. I want to be on the plane here to there, across in the X to that point, lock onto the plane again to that point, and then in the Z straight down to the end there. And you see how it all locks up onto the edge. Now, of course, what we want to do is put some cross members in. So those you go on the Y, down to there. Another one down this way. And another one. In fact, I put one extra one in that I shouldn't have put in, so we'll go back and fix that now. If you want to see how to make mistakes, I'm your man. So that one I don't need in just yet. What I do need in there, we just rotate it round, is again, start drawing some lines. I'm going to pick up the end of that one and go straight up in the Z to that point, and then onto the there on that point. Same again here, end of there, straight up in the Z to that height, onto here and to the end of there. Okay, one more thing that I want to do here, I want to make sure that the end of that is attached to there. You see a little connect icon appear, that's the little square box, it says it's high. The other ones, this means it's parallel to the X. This means the little plane there, that it's on the XY plane. So now I've got almost all of my wireframe built for this, for my truck body, and we've done basically the hard work here. So we can see now that we've got a wireframe that lays out the truck body. I can place dimensions on this to drive them if I want to, but the dimensions are correct for what they were. But we can put those in to change them, and so on. If I need to change those, I can change those, the whole frame will update. But for the moment, I don't need those. The next thing we're going to do is go to the frame. I'm going to use a butt connection. Now this little dialog here allows me to set up how I'm going to place things, and we'll use that a little bit more later on as well. I've already picked up my square tubing, but I've got a library here that I can go through and pick that up, and you can create your own libraries and add your own material. So if I look at that, it was square tubing, and I've got a whole lot in there, and I can go to, we can supply the BHP standards, the Australian standards, if you want them. Okay, so I've placed my framing material on here, and it's overlapped the way I want it to. It's placed all the frames where I want them, with one exception. If we look at our previous sketch here, the edge of this needs to be 100 millimeters away. You'll notice that this frame member here is on the incorrect side. So I can pick the cross sections of the frame and then just use my cursor keys to move them where I want them. I'll just zoom in here a little bit so you can see this. If I move that to the left, it moves half the width of the material each time, so that frame member now is in the correct place. Okay, let's continue on. Now I want to have mitered corners, so when they come around here they miter, and it will automatically position when I place these. So away we go. So I'm just placing these across here. It's always good practice just to set up frame sequences in logical groups. Now, this is quite useful. Here we've seen that those frame members here are out of sequence with the other ones. That's very easy to fix. All we have to do is, again, go to our Modify Cross-Section. Just select the cross-sections we want to modify. And I think it's that one, isn't it? Yep. And we select those, and we just use our cursor position to move them across. So it's just 2 notches. There we go. And they're correct. Now we want to build up the these edge ones here. So here and here. Likewise. No, sorry. Not thinking straight. Put those back on. Back to framing. Okay, so I want to put that one, and that one. The cross ones across the top here. And they're all fine except this one here. I'm not really happy with the position of this one. Let's have a close look at that. We'll zoom in a bit on him. We'll pick up our frames. I'm going to select that one. And now what I'm going to do is to just zoom in on him so you can see him. I'm going to use this icon here, which is define a handle point. And I'm going to actually click on a key point on this material itself. And what I want is that vertex just there. So I've moved it across just that little bit. That's still the wrong vertex. So again, pick my vertex, and I want it to go across to that one, just to bring that into the edge there, just so it's not overlapping. Okay, now we're ready to place these little components in. I can finish that. Okay, again, one thing I want to show you here is I want to turn on coping, so it'll cope around when this frame member comes in here. Put a little bird mouth in there if you like. So again, we're picking our frame members. There we go. And they're tremendous. Now notice again, I've got this frame member here on the left-hand side of the line. Let's say I want it on the right-hand side of the line, which is probably what I do want to do. And again, it's just a matter of picking the 2 sections and just with my cursor just to move those. Now finally, the last one that we want to put in is these 2. And again, they're on the outside of the line, which is fine. We want to move both of those. There we go. Okay. So we've got our fundamental frame put together. I'll just close that frame for a moment so we clean up the sketch a little bit. And you'll notice that all the pieces go together. One of the things that I might want to change is to just edit the sketch 2 here and change this 600 here to, let's say, 800. And it updated, it moved that, moved the line, moved these frames, all these bits extended and so on. So you can see it's very easy to edit, very dynamic, and things work the way that you expect them to. Okay, having got to that point, I'm ready to make a sheet metal cover for this, cut a slot in it and put a door in it. So another couple of minutes, we'll have a sheet metal component placed on here. I might at this stage want to save this. So we go to our save. Okay, so the next thing to do is to create in place. So we're inside an assembly. We use our create in place. I want to use a sheet metal template. I want to give the file a file name, so I'll call it AA_cover. And I want to create and edit that cover part. Now you'll notice now we've got the frame components in a background color, because we're now working in the sheet metal mode as we were before. So I'm going to create some lines basically, and I want to create them on that plane. We lock onto that plane. But to create the lines, all I'm going to do is to include edges from the frame, because that's where they're going to be. And we can see those edges coming up there. And I want to reference one here, the bottom. I want to create one that's in the center. Just up through there. And we're going to do some trimming. So we'll trim those two off, and I'll trim those two off so that goes down to the bottom. Now I don't want those lines to be used for creating my component. Okay, we're ready now to do our contour flange. Again, we pick up the edge. I can start dragging. Here I'm going to say, well, I want it to be symmetric. Come out to this edge here, and I'm going to change the material thickness manually here to 3 millimeters. You saw in the other component how I could go and pick up my my table to do that, and I just want to pick up an end point on here just to make it go to the full length of the frame. So if we fit the screen, we'll see that that's the full length of the frame, except I've made an error here. I made that too long. Look at that, it's overhung because it's not symmetrical. That's very easy to fix. All I have to do is pick up the edge there, turn off my symmetric live rule because I don't want the other end to be affected, and move that back. Again, pick up the end point, there. And it's a perfect fit, as you can see. Okay, I want to create some cutout lines on here, so I'm going to draw again on that face, and I'm going to use my include tool again. My include tool, so include, but this time I want to go into the dialog and I want to say I want to include with an offset. So I'm going to pick the line there, tick that off. My offset, I've done this before, is a 20 millimeter offset. And again, same on the other side. So we're going to do an include with an offset. Pick the outside edge, that one there. Tick that off, and a 20 millimeter offset. Swing round. Now, I'm still on the drawing plane, so I'm just going to put a line in across the top here. Include one off the bottom edge, that's fine. And trim up again. So using my trim tool, and in there. Okay. One final thing that we want is we want to know the exact height of that, and that needs to be 1300. So this is for a cutout. The bottom edge is not going to be cut, so I'll just turn that off. And I'm going to use my select tool to select. My grab and go handle's ready there to push that through. But what I want to do is to do a wrapped cut. So what it does is when I push that through, you'll see it unfolds the bend that went across to cut it through on the normal. And then it places it back, and you can see that edge will be normal to the face. If I just pushed a cut straight through there, that edge would be beveled. Okay. So we're getting there. I'm now going to just deal with my sheet metal component. We don't need to see the sketches, and I'm going to do some other work here. So we're going to start drawing again, and I'm going to do some flanges. The first flange that I want to produce is an edge flange here, so it ropes down over the edge of the sheet metal component. We just can start drawing, and I'm going to use that little face there to draw on. So we'll lock onto that plane. See the lock come up, we're locked onto that plane. Do it down. All right. And we'll come down 45 will do. Whoop. Don't want that piece, do we? Move across. Here we're going to back to my drawing tool. And we're simply going to put some dimensions on that. 50, we'll make that 40, and we'll make that 20. And I want one on the end here again. So it's just a the thing that I need is a center plane to mirror this around, so I can just make a coincident plane on that one and then move that so that it's at the center of the edge here, so at the midpoint of this edge. Right. So I want to mirror this. We go back to our sketching tool. I want to mirror that information in there across that plane. We come up to here, all I need to do is make sure that I connect. Use my connect the end of that onto the end of there. Okay. Okay, we're ready to sweep profiles in here. So very simply, again, we use our contour flange tool. Take that up to there. Contour flange again. So I'm just going to produce these contour flanges. You can see how quick these things are to do. Quite complicated shapes, created very quickly. Contour flange again, there we go, there we go. One thing that I might want to do to make this a little simpler is to put a bevel on these edges here. Let's take you in here and say, okay, what I want to do is to take that one, rotate it around that edge, and we'll make that 45 degrees. There we go, let the thing catch up. And the same at the other edge here. So same thing here. And that will be minus that one, I believe, that angle. We'll see when it comes down. I didn't move it. Problem. There we go. Yep. Helps if you click. Okay, let's return to our whole overall assembly, and we see that that's all nicely positioned in there and everything fits perfectly. We can make changes quite simply, we can add things, we can remove things. We're running a little bit short of time at the moment, as I'll add a component to the video here so that we can show you how I've added a door into this and we hinge that door. I'll go to a completed component of that shortly and you'll see that. But it's what we've got here is the frame that we've created, the sheet metal component around there. One of the things we might want to do to the sheet metal component here is to trim down on the bottom here, so we can take that, edit our sheet metal. We can hide or show the assembly in the background, but very simply I want to do that trim, so there's one way of doing it, there's lots of different ways of doing it. Just draw a sketch on the face here, like so. Then I'm going to connect that sketch so it trims right into the edges, so I'll use my connect tool here, connect. You just see that edge right on there, and the same the other side. That's onto there, and then we want to make sure that that's what did I say, 50 millimeters exactly. And then we use the cut command, and I'm going to use, because it's an open, it'll say, just do that. I want to cut inwards, and how do I want to cut? I just want to cut through some distance, so I just pull that through. And there we go. So if we return to our, just a perfect fit in there now. One of the last things we want to do with this is to, I'll just create a flat of that for you, which I should have done before going up. So in our tools, create a flat pattern. There we go, there's our flat pattern. All very neat. You'll notice that you get the overall size of the sheet of the developed pattern as well, which is very useful, and you can set warnings on that, so if it extends your sheet size and those sorts of things, it will automatically create what you want. It'll automatically prevent you from creating something that you can't cut on a sheet. So let's save that and do the last thing, create a drawing. Now, in the drawing, what we want is to take an ISO view of that. Let's put it in there somewhere, will do for the moment. And what I want to do with this is create a parts list. So, and I want to look at what I'm going to put in that parts list. Now, I want to deal just with the frame for the moment. So I've removed the cover, say OK to that. I'm going to place that parts list so it gives us all the steel sections. On this we can hide, but what you're seeing here is the number, the quantity, they're all ballooned on here, and we can also go to our properties and say in our columns we want to have the cut length in here. So we can put the cut length in there, add that column, and I might want the cut length to be the third item. And there's our cut length. We can change the shape of this and so on. So we've got our cut lengths and quantities. This is very accurate and it's always correct. So we get our item number and quantity, item number, quantity, item number, quantity, and so on. It gives us a complete view. And again, as we saw before, we can insert a sheet. We can bring in our cover, flat pattern, top view, and place that. do our bend table and etc. on that. So at this stage I'm going to open up for questions. So if we've got, before I go to questions, let's come to here. Somehow managed to close down my... The point of what we did, just before I open up to questions, is about productivity. If we compare traditional 3D systems with 2D systems, we get a big gain in productivity. Solid Edge over traditional 3D systems with synchronous technology gives us another boost in productivity because it's so easy to make edits, to create designs on the fly, because we concentrate not so much on commands but on the geometry that we're dealing with and the form and function of what we need to do. So the answer, obviously, is Solid Edge. I'll come back to this again, but we've got our new version launch for Australia. We have a webinar for that next Thursday, this coming Thursday. We'll be having seminars. We've got them booked now. We've got seminars booked for Melbourne and Brisbane. Sydney's coming up, and we'll have the dates for that available probably this afternoon. I will have the dates for that. I just don't have them in this slide. So we've got Melbourne and Brisbane dates there, 31st of August and 7th of September. If you need any information about this, it'll all be on our website. So don't worry about trying to remember it. www.edgeplm.com.au. Okay, questions. Thank you for your patience. We've got a lot of people here probably maybe a little bit bewildered, but if you have any questions, type them into your little question box on your control panel there, and we'll do our best to answer them. I'll open up the audio for our guys. So put John online and Lee, and they may have some comments as well. But if anybody has any comments, questions, by all means just type them into the box and we can go ahead. There was one earlier from Toby about where can you get the video, and as I said, I think the video will be made available via our website later this week. And if you want to get hold of one, by all means, just contact your sales rep or your business development manager, excuse me, and they can show you how to get there. Do we have any questions? So everybody understands everything. This is wonderful. If you do have any questions, don't hesitate to ask John or Lee Northend, John Belsham or Lee Northend. Sorry, John, did you have a comment there?
Yeah, just say thank you very much for that presentation. It was very an eye-opener for me as well, because it's the latest technology of ST4, which has not been released yet. It's fresh on the street, as it were. So if anybody that I've emailed with any questions, please feel free to email me directly via the John at edgeplm.com.au. I appreciate the time you
Thank you. Yeah, that's a good point that John brought up. This is the first time that we've publicly shown Solid Edge ST4, which is the latest and greatest from Solid Edge. And I wasn't making a big thing out of that because the important thing was the productivity from framing and sheet metal environments. Time caught up with us. We didn't put the door on, but I'll add that to the video a little bit later. So if there's no more questions, I might close up now, and by all means email myself, which is mark@edgeplm.com.au, or Lee, or John, or just info@edgeplm.com.au, or you can call us on 1300 883 653. hang on, I do see a question in here. Is there a trial, this is from Gary, is there a trial version so we can have a go at the basics ourselves? There definitely is, and the online training material is available to you with a trial version as well as there's training material within the software itself, and then there's self-paced online training available to anybody. So yes, all you have to do is contact John, Lee, myself, anybody at the company, and we can arrange to get that to you. Not a problem at all. Oh, there's another one coming in, you see. So once I threaten you with signing off, can solid edge handle reinforced concrete design drawings? Yes, it can. There's a number of things here. We've got very large customers. We've got customers doing very large concrete works for mine sites and those sorts of things. They do enormously sophisticated concrete design that's been tied to building design, and everything's interactive. In the drafting, of course, we have all the hatching for concrete and even wood. Lord help us. So all of those things are available in the package. Yes, indeed, not a problem at all. So yeah, if I threaten going away, obviously people have questions. By all means, don't you'll think of stuff later. You might think of stuff when you see the video a bit later. By all means, go ahead and ask questions whenever they come up. We're only too happy to ask them. Look, at this stage, time's drawing on, and as you can probably tell, my voice is going for some reason. Lack of use. I will thank you once again for your attendance, and have a great afternoon. And if you want to attend any of our webinars and you're not sure about when they're on, have a look at our website, www.edgeplm.com.au. Thank you once again, and good afternoon.